Bismillahirrahmanirrahim. Today we will start our third lecture of Calculus 2, in which our topic is continuity. As we have studied limits in our previous lecture, so the continuity and the limits are related to each other. The questions will be solved by the same method of the limits. So, first of all, we should understand that what is continuity. A function f of x, y is continuous at the point AB. We have three conditions: that AB is in the domain of fxy, and the limit xy approaches to AB, fxy exists. And the third condition is that limit xy approaches to AB, fxy, which should be equal to the function of AB. So as we studied in Calculus 1, that our discontinuity was like this. If you have any kind of confusion regarding Calculus 1, you can check that on my channel. I have uploaded that. So like this, we have any x or y approaching from the sum point. Like this, if we approach from the x, we can reach at this point, and from the y, we can reach at this point. We can reach at this point from x and y. But if there is a hole, I have discussed it in the complete detail in one lecture about discontinuity. So you may check that in Calculus 1 lectures. So this is the discontinuity here. This is the hole existing here. But in two variables, we have the discontinuity like this. There is a closed shape, and the discontinuity is existing in between somewhere. So for such discontinuity, we will have three conditions: that our function should exist at 0, 0. Then we will solve according to our limits. And our third condition will be along the all paths reaching at that point. So we will see that at that point the function is existing or not. So starting from the first question, which is f xy is equal to x minus y whole square divided by x square plus y square. For this we have xy if not equal to 0, 0. And we have 0 if xy equal to 0, 0. So first of all, we should consider our first condition, that the function at 0, 0 exists. Because in the question it should be mentioned that discuss the continuity of the function at 0, 0. So starting from the 0, 0, we will check the continuity on 0. So this is our first condition which should be satisfied, that function 0, 0 exists. Now we will prove it, that the limit xy approaches 0, 0, x minus y whole square divided by x square plus y square. So along x-axis, as we did before in the limits, the method is same. We will take the y equal to 0 and then limit y approaches 0. X minus y whole square divided by x square plus y square. We will put the 0 at the place of y. So x minus 0 whole square divided by x square plus 0. X square divided by x square, which will be equal to 1. So now we have to check along y-axis, in which x is equal to 0. So at the place of x we have to put 0. So 0 minus y whole square divided by 0 square plus y square, minus y square divided by y square minus, because of the square this minus will be plus. So we have y square by y square, which will be equal to 1. So now we have to check our third condition, that when we reach from the all paths, should we reach at the same point or not. So now our third condition, which says along all paths, that if we reach from all paths, should we reach at the same point or not. So the condition is y is equal to mx. Now we have to put y equal to mx at the place of y. So limit y approaches mx, x minus y whole square divided by x square plus y square. So x minus mx whole square divided by x square plus mx square. So now we will take the x square common, x square into 1 minus m whole square divided by x square into 1 plus m. So we will have 1 minus m whole square divided by 1 plus m square. We are not getting the 1 which we were getting when we approach from the x and y. So we will say that limit of function does not exist. So the function is not continuous at 0, 0. Which we have to prove, that we have to check whether the function is continuous at 0, 0 or not. So when we solved it, our solution says that the function at 0, 0 does not exist. This is our next question. One question we have did in which the function is not continuous. So we are doing the one another in which our function will be continuous. So now we have to, the question says that we have to check the continuity at 0, 0, where f of xy is equal to x square y square by 2x square plus y square. So starting from our first condition, that function at 0, 0 exists. The second condition says we have to find the limit. Okay, I will write it here. Find limit. So for this, we are starting from x-axis. So along x-axis, our y will be 0. So at the place of y, we have to put 0. X square into 0 square divided by 2x square plus 0 square. 0 in the numerator divided by 2x square, 0 over something is 0. So along y-axis, our x is 0. So 0 into y square divided by 2 into 0 plus y square. 0 over y square goes to be 0. 0 or something is 0. So now as we get 0 from the x-axis and from the y-axis, so our third condition, now we have to satisfy our third condition, which says along all paths, in which our y is equal to mx. So now we have to approach the limit y is equal to mx, x square y square divided by 2x square plus y square. So x square at the place of y we have to put mx, it will be mx square divided by 2x square plus mx square. So we have the common x square, we have to take the common, the x square and the x square from the denominator. So it will be x square into 2 plus m square. So we will be left with mx whole square, okay, mx whole square divided by 2 plus m square. Now as we are having the independent variable is existing, as independent variable is existing, so limit x approaches 0, mx square divided by 2 plus m square. So we have to put the 0 at the place of x. It will be 0 by 2 plus m square, and 0 where something is 0. So here we will say that our limit exists and hence our function is continuous at 0, 0. So this was our third lecture. In our next lecture we will study derivatives.